First off, I'm going to go through some basics about how the pull tool works. And this is going to be a really simple model, but I really want to kind of demonstrate how the functionality of the pull tool really operates. For some of you advanced users, some of this stuff might seem pretty basic, but for some of the more beginner users, this might not seem obvious. So I'm just going to go and start off with a very simple model here. So what I have is a simple, I'm just going to make a simple box. I'm just going to pull that pull tool up into a box. And when I grab the pull tool and I click on faces, you'll notice that the faces, basically go back and forth when I click on a face. And now that seems really obvious, but what actually is happening in the background is, say I put a round on this corner, and then now I double click to select all these three faces. What you'll notice is when I actually click the pull tool, all three faces actually pull out. Now what is actually happening in the background is it is actually pulling or essentially offsetting all three surfaces essentially normal to the vector along the surface of this face. So for example, if I were to round out these edges as well, and then actually double click and selected all of these faces as well, you'll notice what ends up happening is it actually is offsetting all of them at the same time. Now, you'll notice that it might not seem obvious, but if I actually hold the control key, I can actually do the same operation. What actually will not expand or contract the model. It will only expand or contract the actual surfaces coming off of that face. Okay, so it's a very important distinction when you're first clicking on the pull tool that it's actually grabbing the normal of the surface when you're actually pulling. Another thing that's really important is selection. So selection affects the pull tool dramatically. Now, if I just select this face, there's really not a lot going on. All I'm doing is just really selecting that face, and there's really not much else that's happening. But if I actually grab this face and then all of a sudden held the Alt key and selected this bottom edge, what will happen is that this will create a driving geometry and actually pull this around into a round. So if you guys are familiar with actually clicking on the revolve button, you'll actually select the driving geometry and then be able to move that face around. But you'll notice if I look on the side, what's actually happening is the other edges of the face are actually, again, extending tangentially to the edges of the face. But if I actually go and select that top edge, what ends up happening is I can actually pull that around into basically an arc. And what it's actually doing is overriding that tangential behavior. I can even do the same thing grabbing an edge. So a lot of people are not aware that you can actually basically pull an edge around basically from SpaceClaim to actually create a face. So anytime I select an edge, I can actually operate using a round or chamfer, or also I can actually create surfaces from that same behavior. Same as I had before, if I want to override that extension of the tangential at the top, I can just grab the vertex here at the top face, and then again, I will pull that around and actually create a surface. But you'll notice this time it's going to arc around and not extend tangentially. Same thing, I can also grab this edge here and then grab this top edge, and then same thing, I'm pulling that around into an edge. So oftentimes when I'm modeling, I often will create surfaces as opposed to creating solids, not because I'm actually trying to create surfaces, but I'm trying to actually create surfaces to create geometry so I can actually create a solid. Okay. Another thing I'll mention is if I back up to this surface, you can use the pull tool to actually create a geometry on surfaces. So for example, if I grab this point here, you'll see that I can actually create that point and round that out essentially into a round. It's the same thing basically when I have a model, I can actually create a round. It's the same thing when I go back and select just the corner vertex. I actually also create a round on that edge. So for example, if I wanted to create a rounded box, I could just grab these four vertex first and actually round out these 4 vertices, and then after that go up and create a box as opposed to applying them after. Another thing that I'll use with techniques with the modeling tool is I will actually create edges again to create surfaces. So for example, I can grab these edges here if I wanted to create a box and actually pull that up into a surface set. And then I could always, again, grab all of these faces by box selecting from right to left and actually pulling that out into an offset to create a box. Or another way I could take a look at it is I could always double-click these edges and use this copy edge tool over here on the left, which I'm sure some of you are familiar with, and then actually I can just pull and copy those edges inward into that surface, and will actually imprint those 2 faces. So I can always grab this outside surface to create a box, and then grab an internal face to create the bottom as well. So there's lots of different ways to model. The whole point of me showing you this is that the pull tool is not just an extrusion tool or a simple operation tool. Once you understand the fundamentals of the fact that it's actually offsetting faces and it's actually operating on different edges or surfaces, that it becomes a lot clearer on how to actually use it. Lastly, you'll see that here I can even grab these vertices if I wanted to, and I could always create points or edges. So I can actually even grab vertices and create edges here, and then you'll notice that from those edges I can always go and create a surface, or I can create other geometry from there as I go. So that's the really basics of the pull tool. I know that part for some of you was probably a bit boring, but what I'm going to do now is I'm actually going to pull in a real model and kind of cover off what some of the things that I showed you here can be utilized in actually creating models in SpaceClaim here. Okay. Okay, so what we've got here is a turbine blade. And what I'm going to show here, first of all, is how to actually use the repair tool and actually start modeling off of this turbine blade. So the first thing is under the SpaceClaim tab, there's the repair tab. In this repair tab, I use often not just for repairing models, but I actually utilize it to hack together complicated geometry by using some of these functions. But in this conventional case, you'll see that if I look at my structure tree, I essentially have a bunch of surfaces that are not joined together, and I want to actually go back and join them and solidify this before I actually start modeling. So all I need to do is click on the stitch tool. It will go through the edges and then find any edges that are basically not joined together and actually auto extend and then basically create edge connections. What's important to note, actually I'm just going to go turn on my Zoom here. So what's important to note here is that if I go and look in the options panel, when I'm looking at the repair tools, there's basically a tolerance. And so it's very important to look at that tolerance, especially if you're dealing with different type scaled models. So if you're dealing with like really small models, or if you're saying dealing with buildings or airplanes, depending on the scale, it might not pick up any of these gaps. So it's very important to adjust this tolerance as you go to basically find any gaps that might be missing in your repair. Once I do that, I click the green check mark. It'll shoot through the whole model and then join everything together. You'll notice here it's on one surface. Then I click on gaps. I'm sure many of you understand or seen this in the previous training. And then I click on missing faces. And now it's basically picked up on some missing faces. These are basically just surfaces that are missing from the model. I click the green check mark and it goes in and actually goes and plugs those holes with some surface. So let's go through some of the basic functionality here first. I can actually, once it's solidified, go and click the pull tool. Oftentimes when I'm using the pull tool, instead of actually clicking pull, I'll just tap P on my keyboard, and when I tap P, it automatically goes into pull. I can go and adjust the size of these holes. One of the things that I find quite useful is the UpTo command. So if I wanted to readjust that hole to actually match another hole size, I can just click on the UpTo and actually select the outside face of the other hole, and we'll actually go and match the exact same size of that hole. So it's a very useful function. If, say, I wanted to make all of these holes identical, I can just go and click on the UpTo command and actually readjust those sizes quite easily. Okay. If I want to get rid of this hole, for example, I can just click the fill tool and get rid of it. And one thing that a lot of people ask us about is when I'm doing holes, how do I create slots? So obviously, when I create a slot, I can always just grab this, you know, this face and actually sketch a slot by maybe grabbing two circles and then actually putting in some tangential lines, you know, which is kind of like a slower way of creating slots. But what I'm going to show you now is how to actually create slots from essentially a hole. So if I go back in here and I click on pull, I can actually grab the surface, or basically just hover over that surface. And as soon as I hover over the hole of a surface, you'll see that an axis of the hole appears. So when that axis actually appears, I can actually click on the axis of the hole. And the reason why I'm doing this is because I'm going to be pulling on the axis. I'm actually going to be pulling on the hole feature and basically creating a slot. So I can actually grab that hole feature and actually create a slot. I can even do both sides pull and actually create a symmetrical slot by pulling that in both directions. Another one that a lot of people ask us is basically nonlinear slots. So if I wanted to create a nonlinear slot, say for example, I wanted this slot to follow the track of the top of this turbine. Well, what I could do is actually create a driving geometry section on top of this face. So what I'm going to do is I'm going to sketch on top of this surface and actually click on the spline tool. When I click on the spline tool, because I've selected the face where the hole exists, again, if I hover over the line of where the hole is, basically all of a sudden the vertex of the axis appears. So now all I need to do is just click on the vertex of this axis and actually select where I want to place this spline. Right now I'm not being very scientific about it. I'm just trying to demonstrate how to actually create a nonlinear slot. And then now when I click on the pull tool, I can click on this axis of the hole again, and it will create a linear slot if I actually pull it straight. But if I don't pull it straight right away, and now I'm going to hold the Alt key, and I'm going to select basically this spline that I just created. You'll notice that in the pull tool there essentially is this sweep tool that gets activated. So when I do that, it will actually go in and sweep this hole along this track. And then when I let it go, you'll see it will actually create a nonlinear slot along the top of the face. So that's essentially how you would create a nonlinear slot, essentially on top of the surface. Okay, so that covers slots. The next one is if I want to create rounds or chamfers, oftentimes what I'll do is I'll go and select an edge and double-click that edge. I think many of you are familiar with this. I can click on the rounds tool, for example, and I can actually pull that down into a round, and essentially it will apply a basic round. I can even create variable rounds if I want to, but we won't cover that today. And I can also, if I want to, if I back up, in the pull options here, you'll see I have the rounds and chamfer buttons right here. And the rounds and chamfer, I just activate the chamfer, and then I can apply, again, many different options for chamfer. But again, I'm not going to cover all those options today because that's kind of more of the basic stuff. What is important that I like to cover off, though, is essentially the extrude edge and the copy edge. I find this is a very useful tool to basically go in and actually discuss. So for example, say I grabbed this slot and I actually wanted to create a lip on the outside. What I could do is click on the copy edge and actually go and copy this edge on the outside, and actually it's going to create an offset from that edge on the outside. So instead of me having to go and create another surface or another sketch on the top, I can just offset that slot and actually pull that up now into a feature or a boss. So again, that's a very nice feature for me to go in and actually create features without actually going in and recreating sketch geometry. Or if I wanted to create a lip on the outside here, I could click on the extrude edge, and then if I click on the extrude edge and I actually pull that out, it again will create an offset on the outside, and again I can always pull that down and create a lip on the outside as well. So again, this is a very useful feature I find when I'm using the pull tool to actually go in and create geometry without having to resketch stuff. Now let's go and cover off a topic that many people ask about, which is essentially how to create logos on the side of a part or imprint sketches on the side of a part. So I'm going to go in and create a sketch plane here on the outside. So what I did is, actually I'll just back up. I just selected the X and Y axis here in the world origin. I'm going to click on sketch, and then I'm going to click on this move grid tool to basically move the sketch plane in front of the blade. So the reason why I'm doing this is I'm going to click on the plan view button, and I'm going to bring in essentially a logo essentially right on top of the sketch plane. And you'll notice this is like the Futurescape logo, and I'm going to actually pull and adjust the size of this logo because I want to be able to go and imprint it on the side of this blade. Now, what I just did here, this essentially, if you look in my files, this is essentially a TIFF file, but essentially it is a picture file that I brought in. So this is commonly something that people encounter is, say they need to imprint a logo. Maybe they have a PDF drawing or a picture of a drawing or something like that. They need to be able to go and trace or vectorize this image because it doesn't actually have any CAD geometry. Well, SpaceClaim took a lot of time to try to figure out how to do this. So what we can actually do is, first off, if I want to do the manual approach, I can actually go in and just go and trace this picture manually to be able to try to grab the features, you know, on this picture. So that would be kind of like more the traditional, you know, like trace approach. But if you have a lot of detail, this can take a lot of time for me to complete. But this is not a bad idea, especially if you want to be really accurate. I can always hide that picture after and then click the pull tool and actually pull that out into a logo. But let's back up and actually use the vectorizing options in SpaceClaim. So you'll notice here in the tools option, there's this one button called Vectorize Image. And Vectorize Image actually allows me to turn a picture into a sketch automatically without me having to go in and trace it manually. Now this one's a little bit difficult because it has some shading on the outside of the edge, but we're just going to see what happens when I actually click on it. So when I click on the Vectorize Image, you'll notice that what ended up happening is it actually gone and vectorized it the best that it could. It didn't quite grab exactly the geometry that I wanted because you'll see that it's created some gaps on the inside and whatnot, but that's not a big problem because I can adjust the threshold here with my tolerancing, and it'll basically adjust the thresholds of the colors in order for me to try and grab basically the perimeter of what I'm actually looking for. So I think that looks pretty decent. So I'm going to click on the complete button, and when I click on complete, you'll see that it's actually vectorized that image. If I go and hide this image now, you'll actually see on the side it's actually created a sketch from that image. This is a very useful function if you're trying to be really quick with creating logos. If you're trying to be a little bit more accurate, you might want to go and trace it yourself. Now, the problem though is that if I go and hide that model in the background and I look at the sketch, it's created a bunch of extra geometry that I maybe not need. So I might have to go in and actually delete some of these lines, maybe some of them that I don't really need. And then you'll notice as well, if I actually look at the at some of the other geometry, it actually went in and created line segments here along this logo, and I probably don't want it to be line segments. I probably want it to be actually smoothed out into basically a simple geometry, like a simple spline or something. So what I actually need to do now is go into my repair tab and use the 2D functionality to actually go in and clean this logo up. So usually that's, again, the workflow. I go in and first vectorize this image or trace this image, and then after that I might use some of these tools in the repair tab under this fixed curve section, which is basically located right here. And I use this fixed curve section to actually go in and clean up some of this geometry. So I'm going to click on the curve gaps tool, and you'll notice that there's no actual curve gaps to find any edges that are not connected together. So I'm going to just click on the fit curves and select or box select essentially these this geometry. And what I actually want to do first is probably this logo here. I probably want to turn these into splines. I'm going to turn these in the options here. If I click on under fit curves, there's a bunch of different options. It's asking me if I want to fit it towards lines, arcs, splines, or even correct for tangency. I don't want lines or arcs on this one. I actually want to turn it into splines. I'm actually going to only turn on splines. I can actually go in and adjust the tolerance of the spline correction in order to basically make it as clean as possible. So again, I'll just click the green check mark. It's created a simple logo here. Then I can come down here to my picture. So I can go in, again, box select this, not the picture, the text. So I can go and grab the text. I probably want to turn this one to arcs and splines, or arcs and lines here. So again, it's going to go and try to correct as best it can. I think the tolerance is a little bit too high here, so I'm actually going to try to reduce the tolerance here a little bit. So once I have this this logo created, then what I need to do is actually create surfaces from it. So the way I do that is I would go in and go back into 3D mode, and you'll notice that anything that has been closed is actually going to turn into a surface. You'll notice that there's some surfaces that I might not want, and I apologize, the logo could have probably been cleaned up a little bit better, but you can adjust the tolerances later to imprint. But just for showing example sake. So you'll see that I deleted some of the surfaces inside the R, inside the P, and here is my basic logo. Then if I want to imprint this, all I need to do is go back to the Design tab, and under the Design tab there is this projection tool. So I use this projection tool to essentially project this onto the face. So when I click on project, it's going to ask me first of all to pick the faces that I actually want to project. So I go and select essentially, well, actually selected the wrong faces. So I'm going to select these faces here. Actually, these ones did not fill. Okay, so I'll select them again. Go and select these faces here, and that's essentially what I want to project. And I only want to select this face to target. So I click on the green check mark. It's actually going to imprint this face essentially right on the surface. Now, again, what I was talking about before is once I have this imprinted, if I click on the pull tool, I can actually select these imprinted surfaces and actually pull them out to emboss them. And what's important to note is when I do that, what it's actually doing is pulling this out tangentially to the surface. It's not actually bringing it out normal. But if I actually want to bring it out normal, say for example you're doing like a tooling operation or something like that in CNC, what you might actually want to do is do a straight cut. So in order to do a straight cut, when I click on the pull tool, I actually want to select a vector direction first. So I'm going to select actually the axis, maybe this axis here. No, actually not that. I'm going to actually select the world axis to actually pull on the y-axis. And I'm going to actually select the pull direction. So now when I click on pull direction, and pull direction, and then when I select this face here, you'll see it will actually pull it out straight as opposed to actually pulling it out tangentially. Okay, so that's how to actually create a logo. You can either emboss it or protrude it, but it's a very common question that we get from a lot of our clients. Another one that a lot of people will ask me for is how do I actually create tooling or like a fixture or something like that. And one of the common methods that I'll demonstrate to some people is to actually go and grab surfaces and pull out and copy them. So you'll see that what I just did here is I actually created a surface here from the outside. And the way I did that was I went and grabbed this face. And I can either hit Control-C, Control-P. So what I did is I did Control-C up here, copy up at the top left. And I can also click Paste. And when I do that, it actually creates a separate surface set right on of this surface. The reason why this is nice is because, again, now I have that surface. I can also go ahead and pull that into a face or into a solid. Or if I want, I can actually grab this surface and actually pull that out maybe into an offset. So maybe I need to create a bit of a gap on my interface of my nest. So I can always like offset that by like maybe a couple millimeters. And then you'll see that now it's actually created a surface that I can use to create a model. So again, it's just another method of actually going and creating geometry. Is I can always grab any of these faces and copy and paste them, or hold the Control key. And when I hold the Control key, it will actually go and copy and paste that face wherever I offset it to. And I've used this technique a lot for creating models because I'm always trying to extract geometry from the model by just pulling the surfaces out as opposed to actually, recopying or recreating those that geometry from scratch. So again, using that copy, that pull copy option is very useful actually in creating modeling. So that's some basics about how to actually use techniques for actually doing modeling on this turbine blade. Moving on, I'm going to show you a more of a surfacing example now, which will be like a simple stamping part that maybe you need to create some tooling from, or maybe you need to get some nests from. And so you'll see that this is essentially a stamped tool or stamped part that I'm going to actually create geometry for. So first of all, if I want to actually copy and paste these surfaces, I don't, again, need to select one surface at a time. If I double click the bottom of the stamp tool, it will actually go and extend and project all the tangential surfaces on the bottom of this tool, or on this bottom of this part. So the reason why this is nice is now when I click on copy and paste, it will actually go and copy and paste the entire surface set on the bottom of this part. So the reason why this is nice is because now I can actually go and pull on surface edges as opposed to pulling on the entire solid to be able to grab the piece of geometry for the nest that I'm looking for. I don't need to use all the entire part. I can just copy and paste any surface set that I want from a model in order to use it to create my interfacing geometry. I use this technique a lot because oftentimes your parts can be very complicated and maybe you only want to work on a certain section. So oftentimes I will just go and grab this section right here, and I'll just go click copy, paste, and then now I only have to deal with this part of the model as opposed to dealing with the entire model. And don't be intimidated when you're doing modeling with SpaceClaim when it comes to surfacing, because really at the end of the day, this model is just is not a solid. It's really just a bunch of surfaces that are stitched together. So if I go and say, for example, delete that face, it's really just a surface set that's watertight. That's all really these models are. So when you're dealing with surfaces in SpaceClaim, it really operates very similarly to how the pull tool works, in a solid as opposed to doing a surface. So for example, if I go and grab these edges, maybe I want to create a bottom tool for this part. So I need to basically go and extend some of these edges to be able to pull them down. So what I can do is I can use the pull tool to actually pull some of these surfaces down to the bottom. But if I just do one at a time, it might be problematic. So I can actually grab multiple edges at the same time. So say, for example, I grab this edge, and I wanted to grab a chain of edges. I can just go and hold the Shift key and actually Shift select up to this edge over here, and we'll actually grab that entire edge set in order for me to pull on it. Now, when I pull on it, it'll basically go and pull straight, but you'll notice that sometimes it has problems with the offset because it doesn't really know how far to extend the surface, because you'll notice that at the edges, it's actually creating overlaps or gaps. So when I'm dealing with that kind of problem, what I often will do is I'll create another set of geometry that I'm trying to pull up towards if I have multiple surface edges that I'm trying to work on at the same time. And I will just create like another surface set on the bottom in order to pull up to that block. So for example, if I click on the bottom and I created basically a simple surface here on the bottom, you'll see that now with this surface, I can use this surface as a guide to pull these edges up to this surface at the bottom. So for example, I can grab this, these edges and actually pull, again, like I showed before, like grab the selection tool and actually pull this surface down. But if I want to, I can use the UpTo command like I showed before and actually say I want to click up to this surface set, and actually will pull the entire surface all the way up to that face that I created on the bottom. So again, it's a much quicker way if I want to actually go and extend surfaces up to a certain piece of geometry. I will oftentimes use the UpTo command to actually pull edges up to a surface, just so that way when it's extending, it doesn't actually create any overlaps or anything with the model. So again, what I would be doing here is actually trying to grab some of these edges, pulling them down, using UpTo to actually, pull it up towards this edge here. You'll notice that I had a bit of a failure, so I'll have to go and redo that. But that's essentially the technique that I would use. Another thing that I mentioned before is the pull tool can be used on corners as well. So you'll notice here that on the previous model, essentially I had a round here that was located on this model, essentially that I copied over into the surface set. So maybe I don't want to actually have that round, because if I actually have that round when I create the surface extensions, I might actually create problems. So again, I can go and grab this edge and actually pull that round to readjust that round. If I actually click on the pull tool will actually delete the round just like it would essentially in my solid. But you'll notice in this one, it's actually particularly not having the ability to be able to do that. So if one tool doesn't work, I usually try to use another. So again, if I click on the pull tool and pull it down, it'll actually pull it down and do a point and sharpen that corner. So again, if there's some corners that I want to actually go and sharpen, I can actually just use the pull tool to actually go and delete some of those corners in order to basically clean up some of these edges so I can pull them down easier. So you'll notice that I had some problems with that other edge before, because it basically had trouble with this particular corner. So now when I click on the UpTo, having deleted those rounds, it still has that problem. So if I still have that issue, not a problem. What I can do is I'll actually remove that from the selection and click on the UpTo. And I'm going to show you guys another technique that I'll use in surfacing, which is essentially called the blend tool. So say I ended up with a gap, and in this gap I essentially cannot use this pull tool. The pull tool is actually having difficulty extending this, this edge. My backup will usually be the blend tool. So the blend tool allows me to essentially create surfaces between two edges. So what I'll do is I'll grab these two edges here that I created previously related to the surface that I just generated, and I will actually click on the blend tool. And when I click on the blend tool, you'll see that I end up with a surface that's been created between those two edges. So because I've created that surface between those two edges, it's actually created a straight surface across those two edges. But what I actually want to do is have a contour to the curvature of the surfaces that are adjacent to it. So in order to do that, I will hold the Alt Control keys together. So I'll hold Alt and Control. You'll notice that now my selection, when I go around and click, actually turns blue instead of yellow or orange. So I'm going to select actually this edge over here to actually contour that edge. And then the adjacent edges that are on the other surfaces, I will actually select those as well to actually create a tangency at the connection of the edges. So now when I click on the green check mark, you'll see actually, it will actually patch in the surface on that model in order to create that surface set. So anyways, I won't finish how to create the tooling for this this nest, but the point is that when I'm using surfacing, just as a recap, I can use the pull tool to actually extend surfaces, and I can actually use the pull tool to also clean up edges, you know, when I'm dealing with rounds or anything like that. But the point is, if I can't get my pull tool to actually work with the edges, my backup is usually the blend tool, and my blend tool is how I will usually fill in or end off some of those missing surfaces that I wasn't able to fill in using the pull tool. So that's the basics of some of the surfacing I wanted to show. Lastly, we'll cover is meshing. So I'm just going to bring in a mesh file. And what a mesh file is, essentially, some people use STL files or OBJ files and whatnot, and they use these files to do 3D printing or reverse engineering. So this is an example of a scan of a part that that would be you know, partially scanned, because you'll notice there's certain sections here, like for example, when you're using scanners, some of the corners are difficult to capture, so it will actually leave gaps or voids that it was not able to fill. And that's very important to note, because when you're doing reverse engineering, having a clean mesh can make a huge difference when you're actually modeling. So in SpaceClaim, there's actually the Facets tab, and this Facets tab actually helps clean up some of those meshes. So I'm going to show you how the pull tool can actually help you with some of this reverse engineering and 3D printing work. So first I'll click on Check Facets. And I click on Check Facets, you'll notice that there's a bunch of problems here. It says it has multiple bodies. There's some watertight sections that we are aware of. There's also some mesh intersects, which makes it mean double mesh triangles, and also there's non-manifold vertices, which means there's inverted mesh triangles. So what I can do here is I'm going to click on AutoFix and actually go and click on the model, and we'll actually go in through the model and sweep through and plug up all the holes, get rid of all the vertice intersects, and try to make it watertight. So you'll see here that now all those sections that had areas that were not filled in, it's filled in all those areas, and the mesh looks a little bit cleaner than it did before. Now, when I go and start using the pull tool, I can actually use the pull and move tool to actually readjust some of these features. So for example, you'll see here there's a hole in here on the side. I can actually grab one of these facets and then double click, and you'll see it will actually go and grab a section of the mesh. Now, I want to be able to grab the whole hole, so you see there's a little slider here that I can actually grab, and when I pull that slider up, it will actually go and select tangentially as much of the hole that it possibly can. Now you'll notice though that the problem is that there are sections of the hole that had difficulty grabbing. So sometimes when I have problems with some of these models where I have sections to scan that are really not smoothed out, the next thing I will do is actually will use under the Facets tab, I will use the shrink wrap. And what the shrink wrap does is it actually goes and recreates the model by essentially sort of wrapping a blanket surface mesh over what I have as geometry, but with some additional tolerances. So for example, you see here my cap size is at 10 millimeters when I click on shrink wrap, and essentially that is the size of the facet triangles it's going to create. I want to actually make it a little bit smaller, so I'm actually going to make it like 0.5 millimeter. And when I click on 0.5 millimeter, when I click on it, it will actually go and try to create 0.5 millimeter triangles, wrapping this body with those triangles. I'm just going to wait a second and just kind of see what the result is, and hopefully it will give us something that we're pleased to work with. So just give it 1 second here. So here you see if I go and actually look at it now, it's actually smoothed out a lot better. You'll see there's a lot more smaller triangles. That hole on the inside here is actually smoothed out a lot better. You'll notice it looks a lot more clean than it used to. And so now when I go actually double click this edge or one of these facets and actually pull that out, you'll see it'll actually go and grab that hole a lot better than it did before. If I actually want to go and readjust that size of that hole, maybe I want to readjust the size for 3D printing purposes. Maybe I want to create a dowel pin, or maybe I need to undersize it because I want to drill it out later. I can click on the pull tool and actually go and pull that hole a little bit inward, and you'll see that I can actually go and readjust the size of that hole. So I can go and actually do this with many different sections of the model. Like, for example, I could always grab this sections on the outside of this face and actually pull that outward to actually go and readjust different features. So maybe for some small offsets or some adjustments to be able to create some nice interfaces, I can then go and readjust these sizes, even for creating plugs and whatnot in the model. Also, another thing to note is when I'm doing reverse engineering, the UpTo command when I'm doing reverse engineering is actually quite useful. So for example, let's just say I wanted to go and start reverse engineering this model. I can actually go and create maybe a block here on the side to actually go and retrace this block here that I want to go and generate from the reverse engineering of this geometry. So I'm just going to create a 3-point rectangle over here at the bottom. And actually, I'm going to do it from the top. And you'll notice that I'm just kind of roughing it in. I'm not too worried about it being the most accurate, because all I'm trying to do is just get it close enough in order to be able to get the geometry that I'm looking for. And so when I click on the pull tool, I can actually go and grab this face and actually go and snap to different features in the model by using the UpTo command. So I can click on the UpTo command and actually pull this surface outward and select the outside of this face to actually snap up to the side of this mesh. So that's the one thing that's very unique about SpaceClaim, is I can actually use the UpTo command to actually snap the different features of the model without actually having to worry about trying to eyeball where the actual mesh is. So it's a very nice feature, even not just for creating the simple offsets of blocks, but I can actually create like maybe even a round here on the outside. So I can just create an offset for the round. I'm going to use the UpTo command to maybe match that round over here. And so I'm just using this to essentially snap the actual features in the model, to grab the proper dimensions right off of the mesh. Now, sometimes when you're trying to get the intent, you'll notice here this says 2.1 millimeters. Maybe this is close to an imperial model, or maybe this is actually meant to be in millimeters. So maybe it's supposed to be 2 millimeters, so I'm going to go and readjust. But at the very least, it'll get me close enough to the size that it was intended for when it did the design. That's a very important thing when you're doing reverse engineering, is actually be able to go and grab the features and snap up to the mesh dimensions, so you're actually getting an accurate view of what the actual model is supposed to be. Last thing I'll show you is not only can you use the pull tool in meshing. I know this is not supposed to be a pull tool webinar, but you can also use the move tool. So here you'll see when I'm grabbing mesh, one thing that can be difficult to understand is that I need to be able to grab all the mesh. But if I go and grab from the front here, you'll see that it hasn't grabbed the entire mesh. It's only grabbed what's been visible. So say I want to go and move this boss up to a higher height. What I can actually do is go over here in the selection filter. And in the selection filter, you'll see that there's box selection, but there's automatic, visible, and true. What I actually want to go right now is go and click on True. So oftentimes when I'm doing mesh manipulation, I'll actually turn my selection to True as opposed to automatic or visible, because I actually want to go in and select this entire box on the top. Now you'll see when I go and look at it from the side, it's actually selected the entire mesh. So when I click on the Move tool, it will actually go and grab the entire section here for me to pull up, as opposed to just the front that was basically being grabbed from the visible. So that's pretty much it. That's all I had really to cover off for the Pull tool.